Here is a work energy power example problem where we have a Tesla Model S that changes its velocity from 0 miles per hour to 60 miles per hour in 2.8 seconds. We're given the power output of the motor of 762 horsepower, and they're asking for the mass of the vehicle. I'm going to write down what I know in this problem. You have a car that's starting at rest. So I'll draw a little picture here. And this is our initial scenario where we're starting. The car has some mass, which we don't know. It has an initial velocity of 0 miles per hour. In our final scenario, the cars move forward. Same car, but now it has velocity. It has 60 miles per hour of velocity. And the time it took for this to happen was 2.8 seconds. So when a car goes from 0 to 60, it's changing its velocity. And when we're talking about a change in velocity, we're really talking about a change in kinetic energy. And we know that there is some initial kinetic energy here, and there's some final kinetic energy here. And we're also given that there's a power output. The power of the motor is 762 horsepower. And power is equal to the change in energy over the amount of time it took to change that energy. And in this case, the kind of energy that's changing is its kinetic energy. So the change in kinetic energy would be the final kinetic energy minus the initial kinetic energy over that time period. And so what we need to find is how much kinetic energy it gains from going from rest to a speed of 60 miles per hour. So obviously when we start at rest, we have 0 velocity. And so our kinetic energy initially is 0. So whatever we have at the end, the kinetic energy at the end is going to be half of the mass of the car times the velocity of the car final squared. And we have some information. We know we're going 60 miles per hour, so we actually know the velocity of the car at the end, but we need to do a little conversion. 60 miles per hour. Again, it's better, I like to write it this way so we can set up our fence posts. 60 miles in 1 hour. And we want to convert that to meters per second. And we know that 1 mile is 1,609 meters. And 1 hour is 60 times 60, or 3,600 seconds. And so I can open up my calculator. And I can take 60 times 1609 and divide that by 3,600. And I get a velocity of 26.8 meters per second. So that's my final velocity. I also know that my power in horsepower needs to be converted. Create a little bit more space here. And set up a fence post to get from horsepower to watts. And we have a conversion that 1 horsepower is equal to 743 watts. I believe that's the correct answer. And when we multiply, we get 762 times 743, and I get 566,166 watts. And I'm going to check that conversion real quick because I'm not sure. Actually, I'm going to make a correction. The conversion is 746 watts, so we get 762 times 746, so we get 568,452. Apologize for that. So we have our power, we have our velocity, we have our time. So I'm going to take this equation and plug in what I know. My power output in watts, which is a joule per second, is 568 452, and that's in watts or joules per second, which equals 1/2 times the mass times its final velocity, 26.8 squared, minus its initial kinetic energy, which is 0, all divided by the time, 2.8 seconds. So in the numerator we have joules, in the denominator we have seconds, so the units are going to match up. And now I'm just solving for that mass to get to my answer. I'm going to multiply both sides by 2.8. And that eliminates my denominator. And when I do that, 2.8, I get 1591665. And that now equals 1/2 times the mass times 26.8 squared. I'm going to multiply by 2 to eliminate the half. And I'm going to divide by 26.8 squared. And that eliminates and gets the mass by itself. So I'm going to do times 2 and then divided by 26.8 squared. I don't have to worry about parentheses because order of operations does the exponents first. And I end up getting a mass of 4,432 kilograms. It's a little more of what an actual Tesla is. When I created this problem, I gave it a little bit too much horsepower. I think an actual Tesla is right around 2,000 kilograms, which puts it around 4,500 pounds. Hope this is helpful.